Hello, so I'm going to demonstrate in this video how to solve an ambiguous case of law of sines. Now, you have many different possibilities when it actually does come to law of sines. One of which is whenever you have that, um, let's say for example that you have um, that the sine of, let's say, b is greater than 1 with that the side A is less than the height, but that's less than B. So what this kind of looks like is the following, where you have kind of like a hanging length like this. I'll just extend this out a little bit. So this is not a triangle at all, because there's your angle A, and there's your side B. So we can tell that B is greater than A. And then furthermore, you have that there is the height right here. But that doesn't really give us anything. So what we'll say is that there is no triangle. Okay, well, another case is more or less the regular law of sines, where you have that um, it's where you're dealing with like a right triangle. So if you're dealing with a right triangle, then this means that you have A, B, and then you have angle A, angle B, angle C. So in this case, this tells you that the sine of C is equal to 1, followed by saying that, for example, that the height is equal to A, but that's going to be uh, less than, we'll just say less than B. Okay, so actually that should be less than C. Yeah. Yeah, that should be less than C because you want that to be less than the hypotenuse. Okay, so this basically just means that one triangle, or we'll just say one right triangle. Okay, well, the other possibility that you do have is, for example, that you have your original definition where you're saying that basically you have one triangle that can possibly exist. So this is whenever you have the angle A, angle B, angle C, and you have little c, little a, little b. Well, this is whenever you have that the sine of b is less than 1 but greater than 0. But this is whenever, let's see, mm, yeah, so this is whenever you have that, and probably should change that to C actually. Yeah. So what we'll say here is that A is less than or equal to C. So here we basically just have that we need that one of the two sides is bigger than the other essentially. So what this does is it gives us um, one triangle, and we'll just say it like this: one oblique triangle. Okay, so the next step that we'll have here is that we can actually look at, well, what if we had the following such that you have, okay, this is where it gets a little interesting. So you have A, okay, so here we have the following. We have that this is angle B, this is angle A, and this is angle, well, let's be careful with this actually. Um, yeah, let me call this angle at the top, let me just call that C, because that'll make things a lot simpler. Um, Technically, we can probably just leave it out, if anything, because let me show you why. So the reason that it's a little tricky, that I'm not really going to label it entirely how we should, is because we have these two sides, A and B. So A is going to be less than B, but it's going to be greater than the height. So we'll just say that you have 0 is less than sine of B. Okay, so sine of B less than 1. And then you have that the H, actually that should be sine of B sub 1. Sine of B sub 1, and we're going to put B sub 1 right there. So this has to be kind of like the same like before. So we have that the height is less than A, but that's less than B. Now, this is where it gets a little interesting even more, is that we have that the side can be scooted over. So we have that that's going to be something like this, where if we scoot it on down here, well, that moves the side A to over here. So what that means is that we have that side A is right there, and then this angle that forms right here is what we call B2. Now, in the middle, or kind of like right about here, you have that this is going to be your height that we just call H. And what happens is that a right degree forms. So there's a lot that's happening there, but essentially you have that these conditions must be met. You must have that A, you must have that A plus B2 is less than, we're going to have to say 180 degrees. Okay, so these are most of the examples. The other examples that you might have is whenever it's an obtuse triangle, of which that you might have that there's no triangles that exist. But for this one right here, you have that these are going to be two triangles. So we have that this is going to be two triangles that may exist. Okay, so, and yeah, I think back over here, that should be an acute triangle, actually. Yeah, that should be an acute triangle. But I'm not all for, really classification, really. As long as you know how to solve it, then that should be okay. So let me just do one example of finding the case of two triangles, because whenever you have no triangles or one triangle, that's pretty straightforward, that it just has to meet those above conditions. So let's say that we have the following example. Okay, so again, if you want to see examples of when you have one triangle, just look at the previous video in 7.1 and using law of sines. But here I'm going to say that, let's say that we have A is equal to 17, no, 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 no. We're going to say that side A is equal to 35.5 centimeters. We're also going to say that B is equal to 39 39.2 centimeters. And then we also have that angle A is 61.4 degrees, followed by, that's going to be it actually. So more or less, this is your case of side-side angle. Okay, so let's see. The way of which that we're going to do this is we're going to say that let's go ahead and find sine of B. So we're just going to say that sine of A, okay, so sine of A is divided by little a, and that's equal to sine of B, and that's all divided by little b. Okay, so essentially we have that this is going to give us sine of 61.4 degrees divided by 35.5 centimeters. This is equal to sine of B, and this is all divided by 39.2. Now, here's where we'll just have to find what sine of B is equal to. So sine of B is equal to 39.2 divided by 35.5 multiplied by sine of 61.4, and that's degrees. Now, basically what we'll do here is we'll just actually just figure out what value do we get for this. So we're told that we just need to basically just figure out, for example, like what that is. So we have 30, so 39.2. Okay, so 39.2 divided by 35.5, and then all of this gets multiplied by sine of 61.4. Actually, I'm not convinced on that. Hold on. So sine of B. Okay, so yeah, sine of B, and then 39.2. Okay, so yeah, it looks correct. So sine of 61.4, and then we just close that. We hit enter, and we get 0.969. Now that value is actually positive, and it's going to be that if we take the inverse of this answer, you're going to get 75.8. Now notice that if you look for the other angle, 180 minus that, and then you add that to the known angle of 61.4 degrees, you're going to get that that's less than 180. So what that means is that we actually have two triangles. So with that, we need to figure out essentially, like, what the sides will be respectively. So we have that. All that we need to do here is say that we have that side or angle B1 is equal to 675.8 degrees, followed by B2, which is equal to, well, let's do 180 minus 75.8, because we know that there's a second triangle, so that's going to be 104.2 degrees. But we need to still find the sides C1, C2, and the angles C1, C2 respectively. So let's go ahead and find angle measure C1. So angle measure C1 is 180 minus 61.5 or point 0.4 minus 75.8 degrees, and that's going to equal 42.8 degrees. Now, the next step is that you would essentially just say, well, little c1 is divided by sine of 42.8 degrees equal to 35.5 divided by sine of 61.4 degrees. When you do this computation, you'll figure out that little c1, if you multiply by sine of 42.8 on both sides, you're going to find that little c1 is 27.5 centimeters. Okay, so that's going to be c1. And note that c2, or angle c1, was equal to 42.8 degrees. So I found my second, or my first angle. Okay, so all that we need to do is find angle measure C2. Now, angle measure C2, and I know this is a little weird, you have 180 minus 61.4 degrees minus the 10, let me see, yeah, 104.2. This is going to equal to 14.4 degrees. Now, what I want to do here is figure out how to find the little c2 divided by sine of 14.4 degrees equals to, well, it's equal to 35.5 degrees divided by sine of 61.4. So if I multiply this through, I get that c2 is equal to sine of 14.4 degrees multiplied by sine of 35.5 degrees. Okay, that's a, oh, no, that's not correct. Okay, so, yeah, I gotta be careful with that. This is gonna be multiplied by 35.5, and this is all divided by sine of 61. For those that are kind of like just wondering, okay, well, how did you do that so fast? Or, where are you going with this? Just think about it like this. You're just cross multiplying, and then that's what you get. Okay, so we need to just find the small c2. So accordingly, it's going to be, so what did we say? Sine of 14.4 divided by sine of 61.4. And notice that I'm only using the items of which that was already given. And that's kind of like a standard. There are 35.5. Then we hit enter. And yeah, that looks about right. 10.1 centimeters. So we have that this is going to equal to 10.4, not 10.4, 10.1 centimeters. So what that means is that we have that C2 is equal to 10.1 centimeters followed by big C2 is equal to 14.4 degrees. So we have our second set of sides and angles respectively. Now, I would not really technically recommend that you try to draw the diagram as it relates to this problem. I mean, you're going to find that you're going to end up with two triangles basically. So like, for example, it does kind of look like the diagram that I drew earlier where we had that, something like this. And then, so like for example, you have that the angle was 104.2. So that means that the angle mm, has to be more like this then. Yeah, it has to be more like this then. So that means that C2 or C1, no, not C1. Let me see. Yeah, B1, not C1. Okay, so that means that this is going to be not B1. This is B2. Yeah, this is B2. This is B1. A was equal to 61.4. So we'll just put that that's A. So in actuality, this is going to be side A, and then this is going to be our A if it gets shifted. So in any case, it's going to be really difficult to draw to draw the C2. But for example, the 10.1 goes there, but then the whole base, for instance, is C1, which was 27.5 centimeters. So I'm gonna say that it's not really needed to be honest, like about C1, C2, and so on, because like we have that's gonna be B1 all the way over here, and then B2 is gonna be this part right here. Um, yeah. Yeah, so B1 was 75.8, and then B2 was 104.2, but the missing sides, let me see. Did we have our side? Yeah, we did. It was 39.2. So, okay, so I guess that's not too bad then. Did we never use the 39.2 then? Oh yeah, so we used it once, and that was just for the law of sines. Okay, so yeah, let's go ahead and clean this up a little then. Where we say that, okay, that's A, but then that means that B, okay, sorry about that. So we know that B is right there. Okay, so that's going to be it, and that's more or less, the ambiguous case of law of sines.